So we want to change this vector that's in rectangular or Cartesian coordinates into polar coordinates. And if you watch the video about the background knowledge of where all this comes from and what it means, if we got the point -8, -8's out this way somewhere, and then 15's way up here, so I just plot the point -8, 15, and I'm in the second quadrant. But a polar coordinate, instead of going over and up like we do when we plot points, it's an angle associated with it. So what angle gets me to that point, and the distance of this line, which is the radius? Picture a circle being drawn through there, the radius. So it's another way to locate a point. So just one more quick example. So if I put a dot here and I want to know where that point is, I could either count over and then count up and find that point with x, y coordinates, or I could find the distance from the origin to that point, which would be the radius, and the angle made there, which would be theta, angle, and that's how you represent a polar coordinate. So it's just another way to find a point on the coordinate plane, really. And what you're going to see, well, you see it over here in the choices. The first choice, I didn't write it 17, 118. I certainly could have, but I just chose to put 17 angle 118, which is another way to represent your polar coordinates. So let me show you the formulas we need to do to solve this problem. So this is how you go from Cartesian or rectangular coordinates to polar coordinates. So keep in mind, when you go to polar coordinate, you want to find a radius and the angle. So the radius is nothing more than the Pythagorean theorem. All right, so -8 squared, and you're going to do this every time that these questions pop up. -8 squared plus 15 squared equals the radius squared. So we got 64, 225. So you go through here and you solve for r, and we get 17. And then to find the angle made, let me take this off so I can have a little more room. And I think just knowing that the radius is 17 pretty much narrowed it down to which answer is right. So here's how we find the angle. And this formula should look familiar if you did the other quiz in this lesson. Okay, so we use that formula. So calculator, I just put this in, the y coordinate over the x coordinate, and you'll get something roughly around -62. Now keep in mind, this point is in the second quadrant. -815 is somewhere over here, right? -62, let me draw an angle. What we really want to find is the angle from the starting position over here on the x-axis to that dot. That's the angle we want. That -62, or we can call it just 62, is this degree here. So how do I find the part that I really want? 180 minus 62 would lead me to the appropriate angle.